This is the CAPS DBE, November 2022, paper 2, question 1. It's the statistics section for the NSC, the final exam. The matric class of a certain high school had to vote for a chairperson. Okay, the scatter plot below shows IQ of the 10 learners who received the most votes and the number of votes that they received. So here's a scatter plot comparing number of votes to IQ. Before the election, the popularity of each of these 10, so they looked at popularity score out of 100. The popularity scores and the number of votes of the same 10 learners are shown below. So we have popularity score as our X, and we have our number of votes as our Y. Question 1.1.1, calculate the mean number of votes that these 10 learners received. So just to note here, it wants the mean, but it only wants the mean number of votes. So our Y bar is equal to 9 plus 22 plus 10 plus all the numbers in between, 21, 11, and so on, all over the total number of items, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you put this in your calculator, and it simplifies to 15.5 as the mean. Another way you can do this is using your calculator work. If you put your calculator into stat mode, so you press mode number 2, so mode and then 2 puts it in stat. Once you're in stat mode, you want to press number 1. This gives you the 1 minus var. 1 minus var is just for one column. You only have one column. Then you get something, you've got your X values here, which is all your values. You can input 9, then press equals, then you press 22 and press equals and so on. And then at the end, you want to press AC. Press AC, this will store your information. Okay. There's a 1, 2, 3, and so on here. If you notice that you don't have a frequency column, just in the beginning of this video, I want, you should add this frequency column. So if this is not on your calculator, just quickly on how to add this frequency column. So for your settings on your calculator, to add the frequency column, you might not need it for caps, but it's better to have the frequency column added. So press shift, setup. So shift mode is the setup, shift, and then mode is the setup on your calculator. So that gives you setup. And then you want to go scroll down until you see number 3, which is stat. So press number 3 on your calculator, and then it'll say frequency on or off. So you have 2 options. It'll say frequency, and then it'll ask you number 1 for on and number 2 for off. You press number 1, and then your frequency should be on. So if you go back to your mode stats, then if we press 1 minus var, number 1, then your frequency column should be there. If you do it this way, then you should get the same answer. It'll automatically add it all up for you. You press AC, and it'll then the last step, once you've inputted all your information, is you want to go to shift stat, which is number 2. So once you've inputted this information, shift stat. Stat is above number 2. And then the mean is under var. So for me, I think that was number 4. You press number 4. And then the X bar is the representation of the mean. That's the mean. So you press, on my calculator, it's number 2. Number 2. And press equals, and it should give you your 15.5 as your answer. Right. Number 1.1.2, the standard deviation. It's this funny looking thing. It's like a 0 with a little extra line on the top. Is the number of votes of these 10 learners received. If you had done it sort of manually by adding up the number of votes and so on over the total number of people who voted in this from the previous question, then this one you'll have to do using the calculator work. So to get the standard deviation, we go to mode. Let's press mode. Number 2, stat. Once you're in stat, you want to press 1 for the 1 minus var. This is if you just have an X, so you don't have any Y value as well. You're not comparing one against the other. They've only asked for number of votes. Press 1 minus var, that gives you 1 column. So we have 1 minus var, and then you can input all your X values. So input your X values here, 9 and 22, and so on. Just check that you are inputting the right things. So standard deviation is number of votes, which is Y. So that's correct. That's what we're doing. Number of votes. Once you've inputted all your information, you just press AC. This will store it for you. And then you press shift stat, number 4 for var, shift stat. Stat is above the number 2. Press number 4. This will give you var. And we want the standard deviation. So that's number 3. Number 3, it looks kind of like this on the calculator. That's the standard deviation. That will give you the standard deviation. And the standard deviation comes to 4.588 and so on. And you can round it to 2 decimal places as 4.59. Quick recap before we continue to the next question. The standard deviation, if this is your bell curve, your mean would have been Y bar. Your mean is in the middle. And the standard deviation is up to 3 standard deviations away from the mean. And the standard deviation is measurements of a certain distance away from the mean. So that's what we were getting. We're getting that, and this tells us about the data. So this is 1 standard deviation. This is 2 standard deviations. This is 3 standard deviations. And this is -1, -2, and -3 standard deviations away from the mean. So this is what we were working with in the previous question. Number 1.2, the learners who received fewer votes than 1 standard deviation below the mean were not invited for an interview. How many learners were invited? Okay, so in order to get how many were invited, we've got to look at how many were not invited. So first of all, to work out 1 standard deviation away from the mean, we take the mean, and this was 15.5, and we take our standard deviation, which is 4.59. This was to 2 decimal places. And it said that it's one standard deviation below the mean. So we're minusing, below is minusing. So from the bell curve, it's taking us 1 standard deviation below the mean. below the mean. And this comes to 10.91, rounded to 2 decimal places. Remember, we were looking for learners who received fewer votes than 10.91 votes. So fewer than 10.9 votes. If we take a look at our number of votes, then over here, this learner received only 9 votes, and this learner received 10 votes, and then the rest of the votes, 22 is more, 21 is more, 11, 15, 20, 12, 19, 16, those are all more. So only 2 learners received less than 10.9. 2 learners received fewer votes. And there were 10 learners altogether. So we weren't asking how many received fewer, how many weren't invited. We were asking how many were invited. So 10 minus the 10 learners altogether minus the 2 learners that receive fewer votes is 8 learners who were invited. Because obviously the 2 learners who received fewer votes were not invited. Number 1.3, it wants the least squares regression line. This is the line of best fit, also called the line of best fit. So the least square regression line for this data. So now usually your least square regression line is the line, if you had sort of a trend, this would be a positive trend, and then this is a positive trend, and we could have, we did it the other way around, this would be negative. And I'm looking at the data that we have, and I can't see sort of much going on there in any direction, if no matter which sort of, like, try and make a line through the middle there. So that's just for when you first look at it, you can kind of get an idea on the data. This is very spread out. This data doesn't have, there's not a lot of conclusions we can draw from this so far. But to calculate the line of best fit, the least squared regression line is this formula A plus BX. And this is, again, calculator work. So it's just to look at that. This is a line, a straight line, MX plus C, and your B is in the position of your M. But the calculator work is, we can do that first. We can do the calculator work first. So we need, this time you're going to need your, go to mode, number 2, stat. Mode 2 gives you stat. And this time you want to press number 2. Let me just make some little bit of room here. You want to press number 2, which is the, let me see if I, okay. Fantastic. So number 2 gives you the A plus BX, which will give you 2 columns, which is what we want. We want now looks like this. Okay. So now you're going to get the same thing as previously, but you have X, Y, and if you've added your go back in the video, earlier in the video, to check how to add the frequency. This is, as again, I don't know, I prefer to just have it on it. If it's, if you're working, they'll just put 1s there automatically. You don't have to do anything with this frequency column. It's only if you are asked to sort of put a frequency in for Y or for X, then you can use this column. But I just prefer to have it available on my calculator. Okay, so X is generally speaking, always check, but if they don't say X like they have here, then the top one is always your X and the bottom one is always your Y. But here they've labeled it for you X and Y. So X's we put in 32, 89, and so on. 32, 89, and so on. And the Y's, just remember to press equals each time. And then we use the navigation arrows up to number Y. And we start with 9, 22, and so on. Press AC. Then once you've got all your, be careful not to press Shift AC. Shift AC turns off the calculator. Although, if you turn it on really quickly again, it might keep your stored information. But yes, if you turn it off, you risk clearing and having to start again. So press Shift Stat, and that this time we want reg number 5. And at the top there, so Shift. This stat is number 1. Stat is just above number 1. And then we press reg, which was number 5. And this time we want A and B. So if on my calculator, number 1 is a capital A, and you have to do the whole thing again. You press AC, you press Shift, Stat, Reg, and to get B. You get your 2 outcomes. You get your A plus BX. And just be careful, the common error is to sort of put them the wrong way around. So just to make sure that you put your A value in the A position and the B value in the B position. So for me, I get a 1.7709 and so on for my A. And for B, I get 0.2243 and so on. So just check your question. They asked for the actual least square regression line. So your final answer must be written in standard form. It will be 1.77 to 2 decimal places plus 0.22x. This is the final answer for number 1.3. Number 1.4, predict the number of votes that a learner with a popularity score of 72 will receive. So remember, our popularity score was our X values and our number of votes is our Y. So if we take our regression line, this is an actual straight line that tells us about how our X, the popularity score, affects our Y. So our input is the X, and then the output is the Y. So in this case, our input was the popularity score, and our output was number of votes. So this question asked, predict the number of votes. So it's asking for the output with somebody with a popularity score and input of 72. So simply letting X equal 72 is how we find the answer for this one. So then Y will be 0.1770 plus 0.2272. Quick calculator work. And this comes to 17.61, rounded to 2 decimal places. And the final answer, just rounded up to, it's more or less 18 votes. So this is the more or less equal, approximately 18 votes. Number 1.5, using a scatter plot and table, provide reasons why for the following. Why is IQ not a good indicator of the number of votes? Okay, so this comes back to our line of best fit that we had. If you look at the scatter plots, the points that we have on the scatter plot are widely dispersed. They're far away. They're all over the place. So that's one reason it's not a good indication. The points that there's no trend like we had here, positive and negative trends. We don't see anything like that. Another way you could say that is that there's a low correlation between IQ and the number of votes. So you just have to write this answer in words. So for 1.5, you would just write either the points of the scatter, the points of the scatter plot are widely dispersed. Or you could write there is a low correlation between IQ and number of votes. Okay. Number 1.5.2. 1.5.2. Number of votes, there's the prediction in question. Use the scatter plot in the table to provide a reason why the prediction in question 1.4 is reliable. So predict the number of votes against, so we had 1.4 predicted popularity against votes. Popularity against votes. Why is this reliable? Well, reliability relies on our correlation coefficient R. So let's take a look at that. First of all, we can look at sort of how to get R. So how to get R, you obviously hopefully still had your information input from before. And we had the popularity score against number of votes already input, but you could just go over that again. So it's mode stat. Mode number 2 is stat. And then we choose, if you need to do it again, number 2, which is the A plus BX. And this is comparing two sets of, in this case, it was popularity score against number of votes. So it's setting two sets of information against each other. Then we get on our calculator an X and a Y. And if you have your frequency table there, and 1, 2, 3. So this is what it looks like. So we put in all our X's here. It was 32, 89, etc. 32, enter, excuse me, not enter, equals 89 equals, and so on. And then we do the Y, 9, 22, 9 equals 22 equals, and so on. So you've got everything. Then you press AC. Okay. And once you've pressed AC, you've stored your information. Then you press Shift Stat. Shift and number 1, and just above that is the word stat. And this time we're looking for the var, for number 4. Oh, no, that's not where it is. We are looking for number 5, reg. We're looking for, press number 5 on obviously it might differ slightly depending on which model of calculator you have. So just, you want this one. This gives you A, B, R. And if you look at on mine, number 3, it's R. So press number 3 and equals. And then you should get your R. So this is just how to get the correlation coefficient. And R equals 0.9836 and so on. And R is rounded to 2 decimal points to 0.98. And this is the calculator work on how to get it, but I want to just talk a little bit about this R. So R is, it's a number between 0 and 1 that tells us how closely correlated our data is. So it's R is between 0 and 1, and it tells us how closely. Oh, actually, it can also be negative. So hang on a sec. It's between -1 and 1. So if it's if R is 0, there's no. If R equals 0, there's no correlation. Okay, but it's between -1 and 1. So you have, for example, this is a strong positive correlation because it's almost exactly 1. So it's a very strong positive correlation. But we could have 0.98 negative. This would be a strong negative correlation. So R tells us how correlated our data is. And what that looks like on the scatter plot is strongly correlated information is very near together like this. Okay, so that would be a very, very strong correlation, and you have different correlation levels. Textbooks differ, so I would say a very under 4. So if R is smaller than either negatively or positively, if R is smaller than 0.4, it's weak. As I said, different textbooks have this differently. And then after 0.7, if R is larger than 0.7, this is strong. And then in between 0.7, 0.4, and 0.7 is medium. Okay. But in most of the exams, they're looking for, you must know if it's negative or positive, and you must know if it's strong or weak. So to answer the question, it asks provide a reason why. You can say because R is 0.98, therefore the votes to popularity correlation is very strong. Votes to popularity correlation is very strong. Right, that concludes question 1. That concludes question 1.